welcome to Okuma America. Today we're in our Partners in Think facility. We're going to go through a cool little demo that we did in conjunction with WTO. So Matt, tell us a little bit about yourself.
Yeah, so I'm Matt Kelly, product specialist with WTO. WTO manufactures driven tools and static tools for turning centers.
This is a cool little cam pulley basically that was put together between yourself and one of our application engineers. So
yeah, we had a full turret on this one.
This is a MYW machine, meaning we've got live tools on the turret, Y-axis, as well as sub-spindle, which we're utilizing on all the geometry on the part itself. So let's begin by talking about hobbing.
Okay.
I hear a lot about hobbing. That's kind of a buzzword in the industry. Can you hob on a live tool lathe? Let's start basic. Tell me what hobbing is.
Yeah, so gear hobbing, you have a rotating cutter that actually indexes and syncs with the part. And so you can cut straight splines, you can cut helical splines, you can do all kinds of just varied features at a very high level of precision in setup in your machine.
All right, so not only straight, but also helical. Does that
Correct.
Require any kind of B-axis motion to be able to do that?
Yeah, so you've got the motion of the unit, so you have to set it at an angle to match, and that's determined by the profile of the gear and the profile of the cutter. And you also have to offset in the Y-axis of the machine, so you'll need a Y-axis machine, which we have here.
Okay.
And then that allows you can also move the cutter with the Y-axis to improve tool life using different aspects, different sections of the hob itself.
Okay, so working across the geometry of the teeth?
Correct.
Okay, so tell me what hobbing does. How does the hobbing function work?
Yeah, so the hobbing function, you've got your main spindle turning at a specified RPM and a specified clocking location, and then you need your tool to also match that so that each pass of the cutter tooth matches with each pass of the spindle. Because if they're not perfectly synchronized, then you're going to end up, it turns almost into a mill where you just mill away all your teeth.
So you're synchronizing the part turning with the teeth?
With the teeth of the cutter, exactly. And that allows you to have a very precise, very high level of detail and accuracy. We can do up to ISO 1328 Class 8 or AGMA Class 8. We can typically do a class or two better than that depending on the setup, the application, the tooling. You know, everything has to work well together, but when we find that, we can really get a nice profile.
Okay, very good. So what size of hobs or tooling units do you guys offer?
Yeah, so for gear hobbing, we have three different sizes. We have a smaller unit. It's made for smaller machines, of course, and then the mid-size unit, which is what we have here, goes up to 80 millimeter diameter, so a little over 3 inches. And then a large unit, which will do up to a 5-inch diameter. That's for like a BMT 60 through BMT 85 style machine.
Okay.
So the larger mounts.
What are the limitations we get into? I'm assuming part diameter, the swing capacity of the machine, as well as swing capacity of the turret. What limitations would a customer need to look for if he's thinking of doing hobbing?
Yeah, so on our mid-size unit, we go up to Module 3. On the larger unit, we go up to Module 6. And so you got to make sure, of course, there's enough room on the turret to actually swing it around. Our large unit, it's pretty darn big. And then so there's that. There's the size of the hob itself, how big of a hob you can fit on there. If it's too small, if you're doing a really small module, you might not have enough clearance for a larger part because of the swing radius on the part itself.
Okay.
And then, of course, the class of thread or class of spline you're trying to manufacture.
Okay. So another unique feature on this part is the actual keyway slot itself. So that's used a lot for timing and for holding pulleys and things of that nature. So a lot of times we'll do keyway slots using a straight tool, and we're programming basically a box shape with the turret. You guys offer a live tool that is actually a broaching unit itself.
Yes.
Tell me a little bit more about that.
Yes, our broaching unit actually takes all those features and builds them into the unit mechanically. So it extends and then retracts, pulls the insert back and then re-engages. And so this motion happens all automatically within the tool mechanically, so you don't have to do any special programming on your machine. Okay,
so I don't have to program any retraction moves, or it's basically just a straight linear feed in my x-axis.
Right. You just turn on your RPMs and your feed. Our unit, it's a 1-to-1 ratio, so up to 1,000 RPMs or 1,000 strokes per minute, which is 17 strokes per second. We can actually run it that fast and make your keyway in a matter of seconds.
Wow.
Yep, and it's every single stroke, it's retracting and then coming back in, which helps with tool life and surface finish.
So tell me that one more time, 17
strokes per second.
Per second, that's incredible. That's lightning fast when you go into that. Okay. Tell me a little bit about the geometry, the width of the tool, what type of inserts do you use?
Yeah, so insert width limit's about 10 millimeters, available from a lot of common manufacturers. For this demo, we used ISCAR inserts. They offer both form tools and inserted tools. So the form tool, if you have like a really special profile that they don't want to tool up and make a whole, thousands of inserts for, you can get your special profile just for what you need. Or we have the inserts to save costs and be able to change them out very quickly.
Okay. Are you limited on the width of the insert?
Yeah, so the width limit, what's commercially available and what we recommend with our units, about 10 millimeters.
Okay.
That's the max, so a little over 3/8 of an inch.
And how about the stroke itself, the length of a slot that you could produce?
Yeah, so it's a 35 millimeter total stroke, but we need 32 millimeters of effective stroke because at each end we need 1.5 millimeters of free travel, so about a 1/16 of an inch of free travel and about 1.25 inch total stroke.
So that free travel gives you a little bit of lead in and lead out?
Right, that's when the unit, when it comes past the end of the cut, then it can lift without having any pressure on it, and then it can re-engage freely and then make the cut.
Okay, very good. So tell me a little bit about the Quick Flex system for your collet.
Yeah, so Quick Flex has come standard on all of our driven tools.
Okay.
It's a quick change system that also allows you to use ER collets. You don't need a special adapter. You can put the ER collet straight in the unit, or you can use our Quick Flex adapters straight in the unit. No special extra stuff you have to buy.
What are some of the key advantages of the Quick Flex over a typical collet type system?
Yeah, so a couple of advantages. We've got two different tapers. We've got one out at the face that aligns it and sets your depth, and another one at the tail. And so you get better separation between the two, which gives you better run out, better repeatability.
Okay. So what would your typical run out be on a tool like that?
So for run out, we look for a max of 5 microns at 30 millimeters on a test bar.
Okay.
And the repeatability is plus or minus 2 microns.
Okay. And are you able to preset tools and bring them into the tools?
Yes, we have adapters for common presetters. You can preset them. You can have everything set up, within that plus or minus 2 microns of repeatability offline. So you can swap out tools in a matter of 30 seconds or less and have a tool that the position of it almost dead on.
All right, excellent. I appreciate your time today, Matt.
Yeah.
All right, so one of the final features on this part that we're talking about is the engraving that we did on the part. And to talk in more detail, I've got Andy Jones with WTO that's joined me today. Andy, you're the product specialist for the actual high-speed units themselves?
Yes, sir, that's correct.
So tell me a little bit about the CoolSpeed Mini. What is that?
The CoolSpeed Mini is a revolutionary patented turbine-driven ultra high-speed spindle, and it's typically driven by coolant, oil, or air mist.
Okay, so when you say ultra high-speed, define that for me. What kind of RPMs would we typically expect out of that?
Yeah, the CoolSpeed Mini can operate at up to 75,000 RPMs.
Okay, that's cranking. So what would the typical application be? We're obviously using it for engraving.
Yes, sir.
Using small tools. What other applications do you see?
Right, yeah, engraving is a very popular application. We also have a number of customers that do use it for surface finishing or drilling as well.
So you mentioned that it's driven by coolant. So we're not utilizing the live tool station of the lathe itself. So this could be on a standard stick tool lathe, or you could actually use it in a mill as well.
Yes, sir, absolutely. We have a wide variety of models that can fit different machine types or different holder types.
Okay.
So we use either through spindle coolant if that's available, or if not, say like in a Swiss type machine, we could do a point-to-point connection, and we have models that are specifically designed for that as well.
Okay. So what type of run out would we expect to see on a tool like this? I know when you get into micro tools, you can't handle much run out. So what do you typically see on a CoolSpeed Mini?
Yeah, the CoolSpeed unit has a dynamic run out of 4 microns or better,
Okay.
which is significantly better than what a machine spindle could deliver. And the secret to that is the fact that the tool shank is the spindle itself. There's not actually a spindle with a collet that holds the tool. The bearings in the turbine actually get pressed onto the tool shank.
What about maintenance? What kind of maintenance is required on a unit like this?
CoolSpeed is very unique in that it requires no maintenance whatsoever. So a lot of existing high-speed spindles on the market require periodic maintenance, which is also very expensive. But the CoolSpeed Mini, if you need to change the bearings or change the tool, the operator can do that himself with an assembly device that we provide. And it's very quick, and there's almost no downtime.
Okay. So you can set these up inside the turret itself, inside the machine, or you could set them outside and actually preset your tool length and things like that?
Yes, sir, yeah, absolutely. So there's no professional installation required. The operator can do the installation into the machine and also do the assembly outside the machine if that's the way they want to do it. So there's an assembly device that comes with the Cool Speed Mini that actually lets you press the bearings and the turbine onto the tool shank, and then that will insert into the housing, and then the cap gets screwed on, and that's the entire assembly process. It's very simple.
Very good. Well, Andy, thank you for your time today. I appreciate you joining us.
Yes, sir. Thank you for having me.
And thank you for joining us here in our Partners in Think facility. To learn more about Okuma, any of our products, or any of our partner companies, go to okuma.com to learn more.